Hey there, micro folks. This is Mr. Hooker, and today we are looking at Chapter 6, Elasticity. This is all about responsiveness to a change in price. So let's get to it. So, starting off the first example, taken for a ride, um, looking for an ambulance. You take a ride in an ambulance. You go 9 miles. The bill comes. It's $1,700 $1,772 41 cents for non-emergency treatment. How are they able to charge that? Well, you need the ambulance ride. Like, what else are you gonna do? Like, uh, it's price elasticity of demand. That is an inelastic good. Uh, I remember years ago uh, when I first discovered my heart condition, go to the doctor. They do, I felt something weird. Went to the doctor. They ran an EKG. She's like, "Yeah, you need to go down to the ER. You want me to call an ambulance or you want to drive?" Um, it's like 2 miles down. I'm like, "Don't call the ambulance. I'll drive myself." So I drove that one, and then get down to the ER, small town in North Carolina. Um, she handed me the EKG and she says, "Hand them this, they'll take you right back." I go, hand them that, they take me right back, they hook me up, and everybody's like looking at the thing. Look, they hook me up to their own EKG and everybody's looking at it. And then they're like, "Yeah, you're gonna have to go to Winston-Salem." I'm like, yeah. So they called an ambulance and that one I had to pay for, but crazy. Um, so price elasticity of demand is the measure of price responsiveness. The way this works, it's elastic when an increase in price reduces the quantity demanded a good bit. Um, More than the increase in price is the way that works. It's inelastic when an increase in price reduces quantity demanded just a little, basically less than the increase in price. You also have unitary elastic, and that basically means that the increase in price reduces quantity demanded exactly the same percentage as the increase in price. Um, so calculating it, so price elasticity demand is equal to the percentage change in quantity demanded divided by the percentage change in price. So there's the formula for it, percentage change in quantity demanded divided by percentage change in price. Um, so if the price of oil increases by 10% and quantity demanded falls by 5%, price elasticity demand for oil is -5/10 or -0.5. So here's some notes about this. We always know that this is going to end up a negative number, right? Price and quantity demanded move in opposite directions. This will have to end up a negative number. So um, basically, what we typically do is we eliminate somewhere in your calculations, eliminate the negative sign and make this a positive number. We are going to analyze this and we would like it to be a positive number, right? So drop the minus sign somewhere and deal with that, but only for this price elasticity of demand, not for all the other ones. It's going to matter whether or not it's positive or negative for some of these other elasticities we talk about. But for price elasticity of demand, we just want a whole number, right? A positive number. And you'll understand why here in a minute. So what we're going to have to do though is use the midpoint formula. Um, the percentage change calculation depends on your starting point. So gasoline costs 3 times as much per gallon in Europe as it does in the US. What's the percentage difference between American and European gas prices? It depends on which way you measure it. European prices are 200% higher, or American prices are 66.67% lower. So it just depends. We would like that to be the same, just a math thing, right? Um, so it is a thing. So we calculate price elasticity of demand using the midpoint formula for percentage changes. So there's a simple percentage change formula and there's a midpoint method. For elasticity of demand, price elasticity of demand, and price elasticity of supply, you are going to have to use the midpoint formula. For the other elasticities, you can use simple percentage change formula. Okay, pretty simple. So instead of dividing by the initial quantity or price, we're going to use average quantity or price. So basically, it's change in X divided by average value of X times the 100. So let's just move to this whole thing and look at it. So at the initial price of 10, the quantity demanded is 100. Price rises to 20, the quantity demanded is 90. So percentage change in price is 20 minus 10 divided by 10 plus 20 divided by 2 times the 100, or whatever you do to get to the percentages. And actually, that part's not necessary because you're dividing in the end too. So the times 100 thing is not necessary. Um, and then for quantity demanded, 90 minus 100 divided by 10, 100 plus 90 divided by 2. So the times 100 piece is not a necessary portion of this one. And you'll see here, this is what this looks like. So Q1, the midpoint formula is Q1 minus Q2 divided by Q1 plus Q2 divided by 2 divided by P1 minus P2 divided by P1 plus P2 divided by 2. So that's what this looks like. So I'll leave it there for a second. That's what that is. So that's that formula. So the Q1 minus Q2. The key thing is, like, if you had A and B on a graph, whatever your quantity, your price is for A, use that quantity for if that's your price. If that's your price one, make sure that's your Q1. And if you're, so that means that B is 2. So whatever price is for B, that has to be the quantity. That's your P2. And that also has to be your Q2. Just stay consistent. That's the key thing here. Just be consistent. So estimating some elasticities. A lot of people are interested in price elasticities, whether you're consumers or firms. So firms are interested in it because if you have an inelastic good, you can raise the price and make more money. If you have an elastic good, you can slightly reduce the price and increase your revenue. If you're the government, you want to tax inelastic goods. You don't want to tax elastic goods. So estimating elasticity is crucial to understanding and predicting outcomes. Here's some estimated price elasticities of demand. Gasoline in the short run is 0.09. So let me first mention like where everything falls, right? So anything less than 1, assuming that you've eliminated all of the um, negative signs, right? Any elasticity less than 1 is inelastic. Equal to 1 is unitary elastic. Anything greater than 1 is elastic. The further away from 1, the higher than 1 it is, the more elastic it is. And the closer to 0 it is, the more inelastic it is. So close to 0 is highly inelastic. Close to 1 is what we call very unit elastic, and which means that basically people don't care. And so 0.8 to 1.2 is what we call relatively unit elastic. People just don't really care. And way away from 1 is highly elastic. So that's the way you want to look at it. And the way you would talk about that is, let's say that we have a elasticity value of 3.25, right? So if we have an elasticity value of 3.25, what that means is that for every 1% change in price, we have a 3.25% change in quantity demanded. Or for 1% increase in price, there will be a 3.25% decrease in quantity demanded, if you want to be specific. So that's what that means. All right. So back to our little table here. So now that I've explained how it all works, let's get back to this table. So gasoline in the short run is 0.09. Gasoline in the long run is still inelastic, but not as inelastic. It's 0.24. College in-state tuition, zero point 0.6 to 0.75. And there's a reason that they denote that as in-state tuition. In-state tuition is typically cheaper, and therefore we look at that as people are more likely to go to college in-state. And so it becomes a little more inelastic. Airline travel for business, which is more of a inelastic good, like you have to travel, zero point 0.8. Soda, zero point 0.8. In other words, people got to have it. That sugar is kind of addictive. Housing 1.2, that's elastic. College out of states 1.2, that's elastic. Note out of state's more expensive and therefore a little more elastic. Airline travel for leisure, you don't have to fly to go see grandma. There are other options. And also, if it's way too expensive, you'll just go see her next year. 1.5. So Coke and Pepsi, 3.3. So also note, and we'll get into this later in the chapter, but as you know, individual brands are much more elastic, and that is because of definition of market. So broader the market is, the broader the definition of the market is, or product or market, the um, less elastic it is. This is one from a previous book that I had that I love this table. I loved that book. So this is one from a previous one. So books, Barnes and Noble. So think walking into the bookstore, -4. So highly elastic. But books from Amazon, downloading those books, -0.6. zero point 0.6. So much more inelastic. DVDs from Amazon, 3.1. Post Raisin Bran, so a single brand of breakfast cereal, 2.5. Automobiles, 1.95. That really needs to be better defined, whether they're new or new to you. Tide liquid detergent, 3.92. Once again, a single brand. Coca-Cola, 1.2. Yes, it's a single brand, but Coke is kind of the dominant force in that. And like if you're in the South, you could say, I'd like to order a Coke, and they'll ask you what kind. You can then say Mountain Dew, and they'll bring you a Mountain Dew. It is really weird. Um, Grapes, 1.18. Restaurant meals, 0.67. They're inelastic. Um, I believe that just because people have gotten like lazy as far as cooking at home. And so even with the expensive, even though it's become more expensive, I think that number has shifted back to more, a little more elastic, but I think it's at worst relatively unit elastic. I don't know that it's fully elastic yet. Health insurance for low income households, 0.65, bread, 0.4, water for residential use, 0.38, chicken, 0.37, cocaine at 0.28, cigarettes at 0.25, beer at 0.29, Catholic school attendance at 0.19, residential natural gas at 0.09, gasoline at 0.06, which you saw in the last one. Those are about even. Milk at 0.04 and sugar at 0.04. So there's some interesting things there. One of the things that always interests me on that one is that people are more likely to give up cocaine before they stop sending their kids to Catholic school. Just one of those things. Two extreme cases, perfectly inelastic demand is a vertical line. Perfectly elastic demand is a horizontal line. One easy way to remember that, like if you put a horizontal line on each one, kind of toward the top, on the left one, it would create a capital I, stands for inelastic. On the right one, it would make it look like a capital E, stands for elastic. So yeah, helps you out. So basically on the perfectly inelastic one, there's a fixed quantity. The price, you can charge whatever price you want. It's just what it is. They're using a snake anti-venom there. Like you get bit by a very venomous snake, you'll pay whatever you need to get that anti-venom. On the other one, They're talking about pink tennis balls. Like, do you care if it's pink or not? Probably not. So it's a very, it's one of those things that you try to charge more, people are not going to buy it. So one of those deals. Now you can sell whatever quantity you want at that price, but you can sell a specific quantity at that price, but it's one of those deals. All right. Price elasticity of demand. It can be as low as zero, high as infinity. Those are the two cases we just looked at. As I mentioned a little earlier, if it's less than one, it's inelastic, excuse me. If it's greater than one, it's elastic. And if it's equal to one, it's unit elastic. This is where we're going to stop for this video. I'll see you in video number 2.